Number 5 is a vector problem, and we have position vectors OA and OB, vector A, vector B. And it's relative to the origin, that's why it's a position vector. So it says find the value of P for which vector OA is perpendicular to vector OB. So this is basically asking us if we know how to determine if a vector is perpendicular. And the way we do that, as a reminder, is we find the dot product of these, and if the dot product is 0, we have perpendicular vectors. Okay, so our first step is to find the dot product of vector OA and OB. Okay, the way we do that is we multiply each like term and then we add them, we sum them. So we end up with negative 2 times 4 is negative 8. Negative 3 times 1 is 3. And 1 times P is P. Okay, at this point, since it says that they are perpendicular, we are to find the value of P. We set O vector, the dot product, equal to 0. I don't know why I'm rewriting this, it's negative 5. So negative 5 plus P, so I'm going to go ahead and add 5 to both sides. So P is equal to positive 5. Alright, number 2 says find the values of P for which the magnitude of vector AB is 7. So the first thing we need to do is find vector AB. So just as a reminder, this is the notation for the magnitude of a vector, so it looks like absolute value. So to find AB, we need to basically use the displacement property of vectors, or use displacement rule, and take vector B minus vector A. And since these are already position vectors, we already know this is vector B, this is vector A. So I'm going to just set these up, and then I'm going to subtract them. Okay, so when I subtract them, I get 4 minus negative 2, aka 4 plus 2 is 6. 1 minus 3 is negative 2, and P minus 1. And that is vector AB. So hopefully you remember that the magnitude is basically is a distance. So we are going to be using what I would call the distance formula for magnitudes to find the magnitude of AB in terms of P. And I'm not substituting 7 in yet, I'm just going to keep my work really neat here. So the way we do that, just like what we would do with the distance formula, is we're going to be squaring our values. So 6 squared is 36, negative 2 squared is 4, and we're going to add P minus 1 squared. I'm not even going to FOIL that out right now, and you'll see why here in just a second. That's vector AB. That's the magnitude of vector AB. I'm going to go ahead and substitute 7 in here because that's what they said this has to equal. Okay, so this becomes 40 plus quantity. This pen is just not working today. P minus 1 squared. Alright, so my first step is I need to solve for P. So I'm going to start by squaring this whole equation. And I end up with 49 equals 40 plus quantity P minus 1 squared. Okay, that's a minus 1. Sorry, you can't tell. Subtract 40 from both sides and I get 9. And I am now going to square root. And as a reminder, since I am the one square rooting, I don't know if it's 3 times 3 that makes 9 or 3 minus 3 that makes 3. Negative 3 times negative 3 that makes 9. So I need to account for both of them. So that's why I'm throwing in a plus minus there. Okay, so I end up with 1 plus or minus 3 equals P. This is not a sufficient answer because it's not simplified, so we need to rewrite this as 1 plus 3 is 4 equals P, or P could be 1 minus 3, which is negative 2. Okay, that is how you complete number 5.